How about starting, by the way, with problem of the day? And this one says, if a rectangle has 72 square inches of area, name all the integer combinations that make up a possible length and width for that rectangle. All right, let's take a look at this storyline here. Again, not a lot of information given to you, but definitely quite a bit. That doesn't make any sense. 72 square inches of area, and it's a rectangle. So this helps quite a bit in helping us to find the answers, the solutions here. You've got combinations, and what the word integer means, we're looking for whole numbers. And by the way, this is going to be positive because you have to have positive lengths and widths for a rectangle. And remember, the area formula is length times width. So what we're looking for are different ways to multiply to get 72. That's what this boils down to. Now, it sounds a little bit fancy at the beginning, but integer simply means we're not worrying about fractions or decimals and percents and all those kind of little things. We're going to be talking about whole numbers, all right? And by say whole numbers, the positive version. Zero is not going to be allowed either, because if you have zero, there's no way you can get a 72 square inches out of this. So we're looking for numbers that will multiply together. So let's talk about it. Basically, we're looking for, how about it? The list of factors of, you got it, 72. So let's see where we're going. First of all, the easy one we know is 1 times 72. Obviously, a number times 1 gives you that number right back. So that one's easy. It's a strange looking rectangle, but nonetheless, it is an option. Now, let's keep going with this thing. Let's keep going with these things. We have also, 2 will divide in there. This is where we're getting these divisibilities. So we're looking at the number 72, and we're going to think of all the different numbers that can divide into that evenly. Well, I know 2 will go in there, and if I split 72 in half, I'm going to be looking at 2 and 36. So there's our second combination. Now, you starting to think with me there? Some of you are going like, well, Ernie, does 3 work? And sometimes some of you are saying, Ernie, I don't really want to go through and find out it doesn't. There's an easy way to look at that, to check for divisibility by 3. If you'll add those 2 digits together, which in this case are 7 plus 2, if that sum is divisible by 3, the number 72 also is divisible by 3. That's a pretty cool trick. And let's see, does it work here? How about it? 7 plus 2, you get 9. Divide by 3, you will go 3 evenly. So that tells me 3 will work. And if I divide 3 into 72 off to the side here, which I'm going to do, we're going to get, oh goodness, 2 times 3, that gives us 6. We got a 12. Looks like 3 and 24. So we come up now with 3 pairs. Now, if we'll go ahead and drop that bottom, we'll be able to see them. Thank you, guys. Now, you probably figured out, he's not done, is he? I am not done yet, no. We're going to take 4. Now, what the trick for 4 is, if it were a bigger number per se, I just look at the last 2 digits and say, will 4 divide in there evenly? If so, 4 will divide into the whole number. Well, you know, we've only got 2 digits here, 72. And I'm going to go ahead and tell you, 4 will divide in there. And how many times? Well, let's check it out also over here. We got 4. We'll divide it into 72. And I'm seeing, y'all are seeing, I hope too, first of all, 4 will go into 7 one time. And we got 3 left over when we subtract. Remember, we say 7 minus 4 gives us a 3. And now, quick check here, 4 into, well, we got to bring the 2 down, don't we? So we bring that 2 on down, right there, follow the beaten arrow. And now we're talking about 4 dividing into 32. You know what? It goes in there 8 times. And 8 times 4, remember we're doing all this multiplication, will give us that 32. So guess what? 4 and 18, another combination. You say, Ernie, are you done? Well, look at 5. You know 5's not going to work, right? Because you have to have a 0 or a 5 on the end. So that's not going to fly. What about 6? I'll give you a hint. If both 2 and 3 will divide into 72, so will 6. Basically, that's an even number, 3 divisible. That tells me that 6 is going to fly into there too. And you say, well, what about that? You know your times tables? You know your multiplication? How about multiplication facts? And that would go with 6 and 12. Looking good. Are we done? Another multiplication fact, times table as we like to call it. How about it? 8 and 9. We know 8 times 9 is 72. Now, someone's going out there saying, well, what about 9 times 8? Well, it's the same thing, isn't it? In other words, we're looking at integer complements could make a possible length and a width. So we can switch them. Yeah, we can make 9 and 8, 12 and 6, but they're still the same combination. So looks like we have 1, 2, 3, 4, 5, 6 of these all together. And I hope those of you who are at home were able to figure those out along the way, along with me. And that, my friends, there's the problem today.